You have looked at Jupiter your entire life without ever knowing it. On any clear night, it is one of the brightest things in the sky. It does not flicker the way the stars do. It simply sits there, steady and bright and still. And you have seen it hundreds of times and called it a star and looked away. Most of us never learn its name. We never learn that the small point of light we glanced past was the largest world in the solar system, close enough to see with the naked eye, and stranger than anywhere we will ever go. Jupiter is so large that every other planet in the solar system, gathered together into a single impossible world, would fit inside it with room left to spare. Only the Sun is larger, and in the whole history of our species, we have reached out and touched the inside of that world exactly once. 400 years ago, an Italian astronomer turned a small, crude telescope towards that point of light and saw something no one before him had ever seen. 4 tiny stars beside Jupiter, and night after night they moved. They were not stars at all. They were moons circling the planet, and they were the first worlds ever found orbiting something other than the Earth. His name was Galileo Galilei, and what he saw through that little lens quietly ended the idea that everything in the heavens turned around us. Jupiter was not a light. It was a world with worlds of its own, a small solar system inside the larger one, ruled by a planet so vast the Sun itself is the only thing that outweighs it. We would name the probe after him. 4 centuries after Galileo first looked, we sent his namesake down into the planet he could only watch from afar. In 1989, we launched that probe towards Jupiter. 6 years later, in the December of 1995, we dropped it in. It was never coming back, and we knew that when we built it. We built it to fall as far as it could before Jupiter took it. It lasted 58 minutes. This is what it found. From where you are standing, Jupiter looks small. A point of light, one among thousands, easy to miss. It is not small. Take Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune. Take every other planet we have and pour them all into one body and lower that body into Jupiter, and there would still be empty space around it. That is the scale of the thing we sent a machine into. Not a planet like ours, with a shore to land on and ground to stand upon. Something else entirely. Because Jupiter has no surface. There is no ground, no boundary between the atmosphere and the interior. No line you could ever cross and say, here, this is where the sky ends and the world begins. There is only depth. Gas becoming denser, pressure climbing, temperature rising, layer beneath layer beneath layer, going down without any floor to stop it. If you fell into Jupiter, you would never land. You would simply fall until the planet crushed you, and you would still be falling when it did. So we built something to fall in our place. It was called the Galileo probe, and it was about the size of a person. Nearly half of its mass was a single carbon heat shield built to take the fire of entry. Inside sat a titanium pressure vessel, and inside that, a small cluster of instruments to measure temperature, pressure, the composition of the air, the speed of the wind. a transmitter to send the numbers home, batteries to keep it alive for as long as Jupiter would allow. And on the 7th of December, 1995, we let it go. It entered Jupiter's atmosphere at 106,000 miles an hour, fast enough to cross the whole of the continental United States in under 2 minutes. The heat shield glowed white. The deceleration was savage, well over 200 times the force of Earth's gravity, enough to crush a human being in an instant. And the probe survived it. The fire passed. The shield had done its work. And then it began to fall. The parachute opened. The spent heat shield fell away beneath it, dropping off into the dark. And the descent began. Not a plunge, but a long, slow drift, pulled down by gravity, held back by air that thickened with every mile. Above the probe, the sky was still bright. Sunlight was filtering down through the highest clouds, and the pressure here was almost gentle, almost Earth-like, almost a place you could imagine. But it was already changing. Deeper now, and the light begins to die. The clouds thicken overhead. The sun softens and blurs and becomes a diffuse glow. A hint of brightness, and then a memory of brightness, and then nothing at all. The darkness down here is absolute, and the temperature is rising. Not from the sun, because there is no sun anymore. No light of any kind reaching this deep. The heat is coming from the pressure itself. The sheer weight of the atmosphere overhead pressing down, squeezing the gas tighter and tighter and turning that squeeze into warmth. 15 kilometres down, then 30, then 50, and the wind begins. Not wind as you have ever known it. On Earth, wind breaks against mountains and coastlines and forests. It has things to slow it down. Here, there is nothing to slow anything. No mountains, no land, no surface anywhere. Only flow. Jupiter's atmosphere moves in vast, unbroken bands. Jet streams hundreds of miles wide, circling the entire planet without pause. The most violent hurricane ever recorded on Earth reached perhaps 200 miles an hour. Jupiter's jet streams run at 300, and some run faster, and they never, ever stop. There is no season in which they calm. There is no corner of the planet where they do not blow. A storm on Earth is an event, something that arrives and rages and passes. A storm on Jupiter is not an event. It is simply the condition of the place. The probe is inside one now, shaking and still transmitting, still sending its small stream of numbers up through the murk towards home. And there is one storm on Jupiter you may already have seen, without ever understanding what you were looking at. On the face of the planet, in every photograph, there is a great orange-red eye, a swirl the astronomers call the Great Red Spot. It is a single storm, and it is larger than the entire Earth. You could drop our whole world into it, and it would vanish into the churn. And it is old. We have been watching it turn for centuries, since the first astronomers pointed their small telescopes at Jupiter and saw a red mark that never went away. A hurricane on Earth lasts days, perhaps a week or two before it tears itself apart. The great red spot has been spinning for longer than we have had the instruments to measure it. And when Juno flew over it and looked down, it found that the storm is not a shallow thing painted on the surface of the clouds. Its roots plunge hundreds of kilometers down into the body of the planet. A storm with depth, anchored in the dark, feeding on the same deep heat the probe was falling towards. The probe is inside a lesser cousin of that storm now, one of countless bands and eddies that never end, still falling, still speaking. Deeper still. The temperature climbs past 100 degrees, past 200. The pressure builds, 5 times Earth's atmosphere, then 10, then 20. And here, something begins to happen that has no equivalent anywhere you have ever lived. In ordinary life, gas and liquid feel like opposites. One you breathe, one you swim through. The boundary between them is something you can see and feel and cross. The surface of the sea, the line where air ends and water begins. Down here, Jupiter erases that line. The atmosphere becomes too compressed to behave like a gas and too hot to settle cleanly into a liquid. It turns into something in between, something dense that fills every space available to it, that presses in from every direction at once. No surface to push against, no boundary to cross, no floor coming up to meet you. The probe is no longer falling through anything you would recognize as air. It is sinking. At around 23 times Earth's atmospheric pressure, 180 kilometers below where it first entered, the transmitter fell silent. There was no crash. There was nothing to crash against. The heat and the pressure simply grew past what anything we had built could endure. The probe reached its limit and stopped being a probe, and kept going. Past the depth it could measure, past the depth it could speak from, down into the layers below, layers it never reached and never saw and never touched, sinking into a darkness that had never once in the whole life of the solar system been broken by light. And far below it, thousands of miles below it, something was waiting that no machine we have ever made has come close to. Far beneath where Galileo fell silent, deep in Jupiter's interior, something else exists. At a certain depth, thousands of kilometers down, far beyond where any probe could survive, hydrogen stops being hydrogen. Not chemically. It is still made of hydrogen atoms. But the pressure down there becomes so immense that the atoms are crushed together, and their electrons are torn loose and set free. And those free electrons begin to move on their own, carrying electric current through the crush. The most abundant element in the universe. The simplest thing that exists. Squeezed past the point where its own ordinary rules still apply, until it becomes a metal. Think for a moment about what that means. Hydrogen is everywhere. It is in the stars and in the vast dark space between the stars, and it is in your own body. You are made in part of the same element. And deep inside Jupiter, that ordinary thing becomes something that flows like water and yet conducts electricity like copper wire. Something with no equivalent anywhere you have ever been or anywhere you will ever go. This is not a metaphor, and it is not a guess. It is liquid metallic hydrogen, an ocean of it, beginning perhaps halfway to Jupiter's centre and extending downwards for thousands of miles. And there is a stranger truth folded inside that one. Jupiter is not made of the same things as the Earth. No great ball of rock and iron at its heart, or none to speak of. It is made overwhelmingly of hydrogen and helium, which is to say, it is made of the same material as the Sun. Jupiter and the Sun were born from the same cloud, out of the same collapse 4.5 billion years ago. And for a while, in the beginning, Jupiter was gathering mass, growing, pulling more and more of that cloud into itself. Had it gathered perhaps 80 times more than it did, the pressure and heat at its core would have crossed a threshold, and hydrogen would have begun to fuse, and Jupiter would have caught fire. It would have become a second sun. We would have grown up beneath 2 stars in the sky. It came nowhere near, but it is the closest thing to a star that our solar system has, without ever quite becoming one. A world that almost lit. And the metallic ocean turning at its heart is what a failed star keeps instead of fire. You have never been there. No one has. Nothing we have built has come close. And yet we know it is there. We know it the way you might know a room exists behind a wall you cannot open, by what leaks through. Everything we understand about that ocean comes from the outside, from mathematics, from the way Jupiter's gravity pulls, and above all, from the magnetic field. Because Jupiter has a magnetic field, the strongest of any planet in the solar system by far, and a magnetic field like that cannot exist without motion. It needs electrically conducting material, moving, circulating, churning. And the only thing inside Jupiter that could possibly generate it is that deep ocean of metallic hydrogen, turning endlessly in the dark. The field it throws off is enormous. It bleeds millions of miles out into space, far past the moons, and it tells us, clearly, unmistakably, that something vast is moving down there, in a place we will almost certainly never see. And that field does something you can actually look at. At Jupiter's poles, where the magnetic lines come down and meet the atmosphere, there are auroras, the same phenomenon as the northern lights on Earth, the glow you might have travelled a long way to stand beneath. But Jupiter's auroras are not like ours. They are hundreds of times more powerful, vast curtains of light burning around each pole, and unlike ours, they never fade. They burn permanently, fed not only by the sun, but by the planet's own colossal spin, and by particles thrown out from its volcanic moon. Ultraviolet crowns blazing at the top and bottom of the world that no human eye has ever seen directly. They are the visible edge of the invisible ocean. The light at the poles is the deep metal ocean writing its signature onto the sky. There is a price to that power. The same magnetic field traps a belt of radiation around Jupiter so intense that it would kill an unshielded human being in minutes, and would fry the electronics of most spacecraft long before they ever reach the cloud tops. Every machine we have sent has had to be armored against it, and even so, the radiation slowly eats them alive. Jupiter does not simply lack a surface to stand on. It is wrapped in an invisible field that would destroy you long before you arrived. A world defended at every layer against ever being reached. And the probe fell past all of it, past the moons Galileo had found on its way down. Out there, in that same lethal radiation, one of them keeps a secret that has haunted us ever since we understood it. Europa, a moon smaller than our own, wrapped in a shell of cracked ice. And beneath that ice, held liquid by the constant flexing of Jupiter's gravity, there is thought to be an ocean of ordinary water, real salt water. And by some estimates, it holds more of it than every ocean on Earth combined. 2 oceans, then, in one system. One of metal, unreachable, turning at the heart of the giant. One of water, buried under ice on a moon in the giant's shadow. Perhaps the likeliest place beyond Earth for something to be alive. And the probe fell past that moon and its buried sea on its way to be swallowed, carrying no one's eyes, seeing nothing on its way down into the dark. Imagine what it would be like if you could somehow survive it. If you could withstand a pressure millions of times greater than Earth's air and a temperature of perhaps tens of thousands of degrees. You would be suspended in liquid metal. Neither floating nor sinking, just held in place by a pressure so extreme it defies understanding. In a darkness so complete, it has no name in any language built for the world you come from. The ocean would move around you, thicker than water, slower, heavier, flowing in great slow currents driven by the spin of the planet itself. Metallic hydrogen rising from the depths, cooling, sinking back down, over and over, endlessly. And this ocean is old. It is older than the Earth, older than the moon, older than anything on the surface of our world. It has been turning since the solar system was young, since before the Earth was solid, since before the first living thing appeared in our seas. It was already moving when there was no one, anywhere, to look up and wonder what it was. And it is moving now. Right now, in this very moment, thousands of miles beneath the clouds, that ocean is circulating and conducting and generating a magnetic field that reaches farther than the distance from the Earth to the moon. A field that pulses and shifts and answers the solar wind as it streams past. Living evidence of motion in the deepest dark there is. For years, a second spacecraft watched Jupiter from above, trying to read that hidden ocean from orbit. It was called Juno, and it spent a long time mapping the planet's gravity and its magnetic field in extraordinary detail, measuring the way the whole world is shaped by what churns inside it. Juno found that Jupiter's winds run far deeper than anyone had thought, plunging thousands of kilometers down into the body of the planet. It found that the core is not a neat, hard ball, but something strange and diffuse and blurred. Heavy material smeared through the metallic hydrogen rather than settled cleanly at the center. And as recently as this year, that same data was used to redraw Jupiter itself, to measure the true shape of the planet more precisely than ever before. We are still, even now, learning what Jupiter actually is. But return for a moment to those 58 minutes. Because for all the ocean we cannot reach, the probe that fell did send something home. 58 minutes of temperature readings and pressure measurements and wind speeds and composition. The record of a descent through the upper atmosphere of a world we had only ever seen from the outside. It crossed 400 million miles of empty space as radio signals to a room at NASA's Ames Research Center, where a group of people sat listening. And what the probe found surprised them. The winds were far stronger than anyone had predicted, running deeper and faster than the models had allowed. And the place the probe fell into was strangely, unexpectedly, dry. The scientists had expected water-rich clouds, thick layers of ammonia and water vapor. Instead, the probe dropped straight into what we now understand to be a hotspot, a rare, unusually dry pocket in Jupiter's atmosphere, one of the driest regions on the entire planet. It was not that Jupiter had less water than we thought. It was that the probe, by pure chance, had fallen through one of the few dry windows in the clouds. A downdraft, a clear patch, an accident of where it happened to enter. And the temperature was climbing faster than expected too, the heat trapped from below more intense than the models had shown. Jupiter's interior, it turned out, was hotter and more active than we had believed. All of that in 58 minutes. 58 minutes of data from the upper skin of a world. And then the signal stopped. The transmitter went silent, and whatever was left of the probe kept sinking, deeper into Jupiter, past the depth it could measure into the layers it would never reach. Eventually, those remains were crushed and melted and turned to vapor in the deeper atmosphere. The carbon, the titanium, the instruments, everything broken apart by pressure and heat and time, and scattered. The probe became part of Jupiter. There is no marker, no trace, no way to point to any place inside that planet and say, there, that is where it ended. The atmosphere simply absorbed it. 30 years have passed since then, and it is gone. What remains are the 58 minutes. The data, the measurements, the handful of discoveries that caught us off guard, the single, narrow glimpse of something we had no real right to see. And the ocean is still there. 30 years from now, it will still be turning, still conducting, still throwing its field out into space. 300 years from now, 3,000. In a billion years, when the sun has grown hot enough to boil away the Earth's oceans and scorch our world sterile, Jupiter's deep ocean will still be turning in the dark. In 5 billion years, when the sun swells into a red giant and the inner planets are swallowed and gone, it will still be there. And through all of that, across spans of time we cannot honestly imagine, through the end of everything we know. Whatever is left of that small probe will be there too, lost somewhere inside Jupiter. We got 58 minutes. Jupiter got the rest. We are a species on a small, rocky world that built a machine the size of a person and threw it into the largest storm in the solar system, just to listen for 58 minutes to a place we will never stand. The ocean beneath the clouds does not know that we tried. It does not know that we exist. It simply keeps turning in the dark, as it has since before the Earth was born. Vast and patient and utterly indifferent to the small, bright, curious world that once, for 58 minutes, reached in to touch it. And it will still be turning, long after we are gone.